Alrighty, good day everybody. This is Algebra 2, tape number 11. Okay, last Friday we talked about trig a little bit, and I gave you the acronym SOHCAHTOA, SOHCAHTOA. We are going to only talk about the trig functions with respect to the acute angles right now of a right triangle. So, I have a right triangle with the legs AB and the hypotenuse C, the sine SIN, the sine, call that A, call that B, call that C, the sine, abbreviated SIN, of angle A is ratio of opposite side OPP over hypotenuse. So it would be opposite, which would be B over the hypotenuse C. Remember, the hypotenuse is always the side opposite the right angle. The cosine of angle A would be adjacent, cosine, COS, ADJ, adjacent over hypotenuse, which would be A over C. And the tangent of angle A, abbreviated TAN, is opposite over adjacent. So it would be opposite B over A. I could also talk about the trig functions of angle B. It is also an acute angle of this right triangle. So the sine of angle B would be A over C, opposite over adjacent, which is equal to the cosine of A. The cosine of B is B over C, which is the sine of A, and the tangent of B is A over C. A over B. The inverse of that. Sine and cosine are referred to sometimes as cofunctions. We'll talk more about them later, but I know that in a right triangle, angles A and B, the two acute angles, have to be complements. The sine of any angle will equal the cosine of its complement and vice versa. Okay? So if you're given a right triangle and you're given the legs, you can find the three trig functions. And a trig function is nothing more right now. We're talking about the acute angles of a right triangle will always be the ratio of the lengths of sides of a right triangle. We talked about how to use your scientific calculator in order to use trig. So if I gave you an angle of 38.5 degrees and I said find the sine of 38.5 degrees, you would go to your calculator, hit the sine key, which will look like that, and then it'll have a parentheses and you enter whatever you want, 38.5. Make sure your calculator is in degree mode. Remember, I told you there are different modes on your calculator. If you're not in degree mode, you're going to get a very different answer. If you're in radian measure or gradient measure, if your calculator has those three, generally we'll have two, degrees and radians. We will talk more later in the year about radian measure. Right now, make sure you're in degree measure. So you would simply hit sine, enter your degree measure, hit enter, and what will pop out, depending upon your calculator and however many decimal places your calculator goes to, you will get the sine of 38.5, hit enter, and what should pop out is pick to 4 decimal places, 0.6225. Okay. Now, we also talked about the inverse trig functions, which looks like this on your calculator, hopefully. Here you're looking for the sine of a given degree measure. If you're looking for inverse sine, they're going to give you this measure, and they're going to say what angle has that as its sine. So you would hit second function, sine, or if you have an s to the minus 1 key, just hit that, 0.6225. When you hit enter, what should pop out is 38.5 degrees approximately. I rounded this answer, so you may get 38.49 something. Okay, so that's how you use your trig functions, and these are called inverse trig functions. In one case, you're given an angle, and you're asked for the trig value of that angle. In this case, you're given the trig value, and you're asked what angle has that as its particular trig function. Okay, so let's go over the homework that was assigned. And you had problems from lesson 43 and 44. In 43, 7, 8, 9, 14, 18, 22. So number 7 said, use a calculator to evaluate 417 times the cosine of 51.5 degrees. So again, you can enter this all in one fell swoop depending upon the calculator you have. Some will allow you to do that. Some you might have had to have done in 2 parts and then multiplied the answers. My calculator, I simply hit cosine 51.5 degrees and approximate, again, rounding, this is 0.6225. And then you multiply that times 417 and you get 259.6 approximately. I'm rounding. Okay, B was 32.6 times the tangent of 86.3 degrees. So again, you would put in your calculator tangent 86.3, and what should have popped out is approximately 15.46. So you get 32.6 times 15.46. And again, when you multiply that out and around to 2 decimals, that's 504.12. So hopefully you had no problem doing those. Do them on a calculator. Number 7. Number 8. Number 8, they gave you a series of triangles. The first one looked like this. It's a right triangle. They told you this is angle A, and this was 7.6, this was 5, and this was 5.74. And here they said find the sine, cosine, and tangent in the triangle and do it to 2 decimal places. So in part A, they said find the sine of A, the cosine of B, and the tangent C, the tangent of C. And this is the first one. This is they wanted the sine of angle A. Well, I know that so the sine of angle A is SOHCAHTOA, S-O-H, opposite over hypotenuse. So the sine of angle A is equal to 5 over 7.6, which is equal to 2 decimal places, 0.66. They didn't even ask you to find the angle, they just wanted you to find the sine of the angle. If you were then asked to find the angle, you would hit second function sine. You do this. Plug that in your calculator and see what pops out. They did not ask you to do that, but you could have done that. That's part A. Part B, they gave you the following triangle. Right angle, here's angle B. They said this was 6, this was 7, and this was 9.2. And they said for B, find the cosine of B. The cosine of B is adjacent over hypotenuse, 7 over 9.2. And they said round that to 2 decimal places, that's approximately 0.76. Again, that's all they wanted. They didn't want the actual angle. They wanted the cosine of the angle. And the last one, they gave you a triangle with angle C. They said this is C, and this was 6. There's the right angle, 10 and 8. And they wanted the tangent of angle C. So the tangent of angle C is equal to opposite over adjacent, 8 over 6, which is 4/3. 4/3 is 1 to 2 decimal places, 1.33. Okay, that's number 8. Okay. Number 9. This was one of those ones where they asked you to convert. They said convert 4 cubic feet into cubic inches. Well, again, hopefully you remember this. 1 cubic foot in inches is 12 by 12 by 12. So it's 12 cubic inches cubed. So if I have 4 cubic feet, then you're going to have 4 times 12 cubic inches. And I just did it out on my calculator, and it should have been, I don't know if they asked you to or not, 6,912 cubic inches. So 4 cubic feet is going to equal 6,912 cubic inches. Again, keeping in mind that 1 cubic foot would be 12 by 12 by 12. 12 times 12 times 12 is 12 cubed. 4 times 12 cubed, 6,912 cubic inches. Number 9. Number 14. Number 14, they said solve by factoring, and this one in number 14 was wait a minute, I think I might be doing the wrong problem. 13. 14. Yeah, 14. Negative x cubed minus 9x squared equals 20x. Bring the 20 over and get minus 20x equals 0. I told you it's always better if you have your highest degree term positive, so I've got two options here. I can either factor out a negative x, or I could just say multiply both sides of the equation by negative 1, and all of these signs would change. Negative 1 times 0 is 0. Either way, you're going to get the exact same answers. I'm just going to factor out a negative x. This becomes x squared plus 9x plus 20 equals 0. So negative x times x, 4 and 5, they're both positive. Make sure x times x squared plus 5 plus 4x is plus 9x. 4 times 5 is 20. Once you have it factored, set each factor containing the variable equal to 0 and solve. When you set negative x equal to 0, that still means x is 0. When you set that equal to 0 and solve, you get negative 4. When you set that equal to 0 and solve, you have to subtract 5. You get x is negative 5. So for number 15, your three solutions are 0, negative 4, negative 5. Okay. Number 18. Number 18, 16 to the negative 3/4 power. That's equal to 1 over 16 to the positive 3/4, which is 1 over the 4th root of 16 cubed, which is equivalent to 1 over the 4th root of 16 quantity cubed. And I did that because 16 is a perfect 4th power. 16 is 2 times 2 times 2 times 2. So this is 1 over 2 cubed, or 1/8. Hopefully everybody followed that. Hopefully you're starting to catch on with exponents that are fractions. And again, very, very quickly, x to the a over b power can always be written as the numerator is always the exponent of the number under the radical, the radicand, and this always indicates the index. And your other rule for this was, if you wish, you can rewrite that as x. The a can come out, so you can first take the b root of x and then raise that to the a power, which is what I just did in the last problem. This will make your life a whole lot simpler in lots of cases. Okay, that was number 18. Number 22. Number 22, I'm sorry, I told you something in class. I misread this problem. They said that's A, that's B, that's 4. They told you these two angles are equal, therefore this is an isosceles triangle, which means that A and B are also going to be equal. And they said the altitude of the isosceles triangle, the altitude is also 4. I'm sorry, I misread it in class. I thought they only gave you that as 4. But they told you the altitude is 4. hopefully you remember when we talked about isosceles triangles, when you draw an altitude, it bisects the base. So what I have here are two congruent right triangles with the legs 2 and 4. Therefore, I know A is going to equal B, and I know that A squared will equal 2 squared plus 4 squared. So A squared is equal to 20. So A is equal to the square root of 20. 20 is 4 times 5, which is 2 root 5. Therefore, both A and B are 2 root 5. And the reason I knew A and B were equal because these angles are congruent. If two angles are congruent, the sides opposite are congruent. Isosceles triangle theorem. So again, I apologize in class. I told you that you couldn't get a numerical answer. I thought they gave you only this side was 4, but they also told you that the altitude was 4. So you had to remember that the altitude splits the base in half, and I now have the two legs of a right triangle and use Pythagorean theorem. Okay. I apologize for setting you on the wrong course there. Okay. That was it from 43. All right, in lesson 44. 1, 6, 7, 8, 15, 17, 18, and 22. All right, number 1. Number 1 said a secret number was unearthed in the Mayan ruins. When that number that was unearthed was increased by 5, and this sum was then multiplied by -2, the result was 18 greater than 6 times the opposite of the secret number that you dug up. What was that secret number? So let x equal the number. And it said that when you add 5 to that number and then multiply that sum by -2, this quantity is 18 more than 6 times the opposite of the number. Well, if that's the number, the opposite of the number is -x. It said you have to multiply it by 6, and it said this number is 18 more than this product. So add 18, or I could have subtracted 18 from that side, same thing. So now you just have a first degree linear equation. Multiply through and simplify. You get -2x minus 10 is equal to -6x plus 18. Add 6x to both sides and you get 4x. Add 10 to that side and you get 28. Divide and you get x equals 7. The secret number was 7. Check it. 7 plus 5 is 12. -2 times 12 is -24. 6 times -7 is -42. -42 plus 18 is -24. So it works. -24 equals -24. Again, with a word problem like that, always read it all the way through before you start to try to define things, or you're going to make a mistake. It's easy to make a mistake. All right, number 6. Number 6 said you've got a right triangle. It said use the trig functions as necessary to find the missing parts. So in this first one, and I don't know why they put the angle like B. This is angle B. They said this was H, the hypotenuse. They told you this is Y, and they told you this is 28 degrees, and this is 9.5. Alrighty, so I've got a couple of options in this particular problem, more than a couple. Alrighty, let's use what we've got right here now, and I can solve for either Y or H using that angle. I know that the sine of this angle is opposite over hypotenuse. Well, that isn't going to help me because I don't know what y is. I don't know what h is. So let's see if we can do it with something else. Cosine. I could use cosine. The cosine of 28 is adjacent over hypotenuse. There I have two knowns, only one unknown. So I could write the cosine of 28 degrees is equal to 9.5 over h. Multiply by h, and then divide by the cosine, and you get h will equal 9.5 over the cosine of 28. And again, you can just plug that in your calculator now. What should have popped out is approximately 5.05. That's one way to do it, using cosine. Okay. I can solve for y. Excuse me. That's not. That is. That's the. This is 10.19. Take that back. 10.19. To find y, once I've got this, I now could say the sine of 28 is y over 10.19. Or the tangent of 28 is y over 9.5. Either or, you're going to get the same answer. So again, once you have solved for side h, I can then find y by using the angle 28 and that side and that side. The sine of 28 is y over 10.19. Likewise, I also know the following. Since this is a right triangle, if that's 28 degrees, I know this is the complement. The complement of 28 is 62. So I could have used 62 degrees to find h. I could say the sine of 62 is 9.5 over h. You're going to get the same answer, 10.19. So I've got a multitude of different answers or different ways of approaching this problem using different trig functions and using the fact that in a right triangle, the two acute angles are always going to be complements. Complement of 28 is 62. So I could have said, okay, this has to be 62, therefore the sine of 62 is 9.5 over h. Cross multiply and solve. And likewise, I can say this. The tangent of 28 is equal to y over 9.5. Therefore, y is equal to 9.5 times the tan of 28 degrees. You plug that in your calculator and then approximate to 2 decimal places. That's the one that pops out as 5.05. Okay, so y is approximately 5.05 and h is approximately 10.19 to 2 decimal places. And again, in 6, 7, and 8, you're going to have a multitude of possibilities to find these. You can use different trig functions, and you're going to get the same answer, assuming you don't make a mathematical mistake. So the next one, a right triangle. And again, in this one, they told you that this is 31 degrees. This is m. That's x, and the hypotenuse is 14, and this is b, angle B. Well, angle B is easy. Angle B is the complement of 31, which is 59. So I've already solved for B. And now I can find m and x using either of these angles. The sine of 31 is x over 14. So x will equal 14 times the sine of 31, which is approximately 7.21. Now I can use trig to find the other one. And actually, once I've got two sides of a right triangle, I could also use the Pythagorean theorem if you want. I could say that 14 squared is equal to 7.21 squared plus m squared and solve. It doesn't matter. Again, as long as your math is correct, you don't make any math errors, you're going to get the same answer whether you use trig or whether you use Pythagorean theorem. But let's go ahead and solve for m now. The cosine, I can use either cosine or tangent now. I could say the cosine of 59 is m over 14. I could say the tangent of 59 is m over 7.21. I could say the cosine of 31 is m over 14. I could say the tangent of 31 is 7.21 over m. All of those will yield the same answer. Or like I said, you could use Pythagorean theorem. M squared plus 7.21 squared has to equal 14 squared. Any way you do it, as long as your math is correct. Again, if you don't make a simple math error, you'll get the right answer. I don't care which way you do it. I did it using 31, and I said the cosine of 31, cosine is adjacent over 14, m over 14. So 14 times the cosine of 31 is equal to m, and m to 2 decimal places. Well, actually, this worked out to be 12. So m is 12. Okay? Hopefully everybody followed that one. On the last one, you had a triangle that was, again, a right triangle. They told you this is A, this is B, X, 4, and 7. All right, now, I can solve for X right away using Pythagorean theorem. Or I could solve for one of the angles using an inverse trig function, and then use trig functions using that angle. Let me do it for you both ways and show you what I mean. I know that x squared plus 4 squared has to equal 7 squared. So x squared has to be 49 minus 16, which is 33. So x equals the square root of 33. X equals the square root of 33 is approximately 5.75. So there is x. And I had to solve for x first because I don't have any angle measures. I don't know what angle A or angle B are. But I could have first solved for angle B or angle A. If I wanted to solve for angle B, I've got the opposite side and the hypotenuse, cosine. For angle A, I've got the sine, opposite over hypotenuse. For angle A, I could use cosine, adjacent over hypotenuse, and use my second function key. So if I did that, I know that for this one, I know that the cosine of angle A is 4 over 7. Which means if I go the inverse cosine of 4 over 7 will equal angle A. So you put that in your calculator, hit enter, and what should have popped out is angle A is approximately 55.2. You have 55.15 something. So it's approximately 55.2. Again, now I don't even need to use trig again. I can simply say angle B. These two angles have to be complements. The complement of 55.2 is 34.8. So there are all the missing parts. And that is number 6, 7, and 8. The next one was number 15, 25p squared minus 81 equals 0. Hopefully you recognize this is a difference of two perfect squares. That's 5p times 5p, that's 9 times 9. Anytime you have the difference, it has to be minus. The sum of squares, I've told you, prime. Difference of squares is always factorable into the product of the sum of the square roots times the difference of the square roots. Square root of 25p squared is 5p. Square root of 81 is 9. So it's the sum times the difference. Therefore, when you set each of these factors equal to 0, you get p is equal. Subtract 9 and divide by 5. You get 9/5 and negative 9/5. So you can write it that way if you want. Plus or minus 9/5. This one will be positive 9/5. This will be negative 9/5. The two solutions are that. And again, you can write it that way, or you can go 9/5, comma, negative 9/5. They mean the same thing. Just go plus or minus 9/5. Okay, number 17. It's another one of those division problems that we're going to turn into a multiplication problem by inverting the fraction that we're dividing by, and we're going to factor all the numerators and denominators into prime factors. Once we have that done, we can then cancel common factors. All right, I am going to, right off the bat for number 17, I'm going to take that numerator and I'm going to take out the common factor x, and I'm going to put the highest degree term first. So it's going to be x squared plus 9x plus 14 over. And I'm going to factor the denominator right away. X and x, 3 and 2. I want the negative x, so it's minus 3, positive 2. That's not factored totally because I can still factor the numerator. Times. When I invert the second fraction, the numerator becomes x squared plus 10x plus 25, which factors into x and x, 5 and 5, plus and plus. And just leave it like that for right now. If you write that, you could also write that as x plus 5 quantity squared, but I'm going to leave it like that because I think we have a common factor coming up. The denominator becomes, and I'm going to bring out the common factor x, and you get x squared plus 10x plus 12x plus 35. All right, so now we are going to continue by factoring this, and I get x and x. 14 is 7 times 2. Both are positive. That will give me a middle term of 9. Plus 2x plus 7 is plus 9x. Over x minus 3, x plus 2, times x plus 5, x plus 5. The denominator is x times x and x. Factors of 35 are 7 and 5. They're both positive, which would yield a middle term of 12x. Plus 5 plus 7 is 12. Now I have everything completely factored. I have all multiplication in numerator and denominator. You can cancel common factors. Anything that's common in the numerator and denominator, anything over itself is 1. So I can get rid of this x and that x. That's 1. That and that over itself, 1. There's an x plus 7 and x plus 7, 1. There's an x plus 5, there's an x plus 5, 1. That's all I can cancel. What is left is x plus 5 over x minus 3, and you are done. You cannot cancel the x's. You can't do anything else. This is now prime. Your simplified answer, x plus 5 over x minus 3. Okay? Number 17. Next problem, number 18, 1 over negative 32 to the 4/5. All right, this negative sign is not affected by that exponent. And I'm going to convert this from a fractional exponent to radical form. Remember, I've told you, when you have a fractional exponent, the numerator is always the exponent of the radicand, the number under the radical, and this is your index. So what they're asking you for here is the fifth root of 32 to the fourth. Now, 32 is a nice number. It's 2 to the fifth. It's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 is a perfect fifth power. So I'm going to use that property that we had, and I'm going to say the fifth root of 32, and it's minus the fifth root of 32 to the fourth. The fifth root of 32 is 2, so this becomes 1 over minus 2 to the fourth, which is 1 over negative 16, or minus 1/16, or negative 1 over positive 16, any way you want to write it. But the answer is negative 2 to the fourth, negative 1/16. Okay. And the last problem, number 22. Number 22, 3 root 6 times the quantity 2 root 6 minus root 12. And I'm going to just go ahead and multiply through first and simplify at the end. I could simplify that radical first, but there really is no need. I'm going to simplify when I finish. This becomes 6. 3 times 2 is 6. Root 6 times root 6 is 6. Minus 3. Root 6 times root 12 is root 72. 6 times 12 is 72. 6 times 6 is 36. Minus 3 times, this is the square root of 36 times 2. So it becomes 36 minus 3 times 6 root 2. The 6 comes out. So the simplest form, 36 minus 18 root 2. 36 minus 18 root 2. And that's your answer in simplest form. Okay, again, as always, if you have any questions on any of these problems, please write them down, bring them Friday, or email me, give me a phone call. Okay, 1 second, I have to plug in. My battery's going down. Alrighty, I'm back. Okay, that was all of your homework. Hopefully it was clear. And I only want to go over one section of work today. And they talk, it's again, they're stressing the difference of squares. Anytime you have something like this, difference of squares, the difference of squares is always factorable into the sum of the square roots times the difference of the square roots, always. Okay? Now, something else I want to stress. If I gave you this problem as opposed to these are two very, very different problems. This is a quadratic equation. I have a variable raised to the second power. A quadratic equation has to have two solutions. The two solutions you're going to get here are plus or minus 3. They both work. 3 squared is not, or plus or minus the square root of 3. The square root of 3 squared is 3, minus root 3 times minus root 3 is 3. You can think of this as the following. Even though 3 is not a perfect square, I can treat it as a perfect square if I do the following. If I rewrite it, the square root of 3 squared is 3. minus the square root of 3 squared is negative 3. Therefore, this and this are exactly the same, and now I actually have this written in the form a squared minus b squared, and you get x plus root 3, x minus root 3 equals 0, so x is equal to root 3 or negative root 3, which is the same as plus or minus root 3. You can write it either way. These, same as saying plus or minus root 3. So even though it doesn't look like it, you can treat anything as the difference of squares if you rewrite it to meet the form that you need. And I said this is very different than this. If I said x is equal to the square root of 9, that's a linear equation. It's a linear equation. You're only going to get one solution. If you start with something like this, you only want the principal root. Here you're only going to get x equals 3, not 3 or negative 3. You only get one solution. Here I need to get two solutions. I'm going to get a positive and a negative solution for x. Those two are root 3, negative root 3, plus or minus root 3 work. So I can take pretty much anything and make it look like a difference of squares. All right? So if I had something like this, I could rewrite that as x plus 17 squared minus 2 equals 0, which is x plus 17 squared minus the square root of 2 squared equals 0. I now have it in the form that I need it. Perfect square minus a perfect square. The square root of this quantity is x plus 17 plus root 2 and x plus 17 minus root 2. So there are your two factors. Set each factor equal to 0 and solve, and here I get x is equal to negative 17 minus root 2. This would be negative 17 plus root 2. So there are your two solutions. Okay? The same will work if you have a fraction. And by that I mean the following. X plus 2/5 quantity squared is equal to 3. X plus 2/5 quantity squared equals 3 is the same as saying x plus 2/5 quantity squared minus 3 equals 0. So x plus 2/5 quantity squared minus the square root of 3 squared equals 0. Again, 3 is the square root of 3 squared. Now I have the difference of squares, and I get x plus 2/5 plus root 3 times x plus 2/5 minus root 3 equals 0, and I get x is equal to, when you take this and set it equal to 0, subtract, and you get negative 2/5 minus root 3, comma, negative 2/5 plus root 3. Those are your two solutions. Okay? So, you're going to see a couple problems like that tonight, or for homework whenever you do it. And I only want to talk about this section, and Friday we will talk about the next section, 46. And I doubt that I will give you homework over the Christmas break. But we will talk about the next section. We'll do some work in class. Okay? So, let me give you the problems I want you to do for Friday from lesson number 45. Please do the following numbers. Please do 5 through 12, and then 18 through 21. 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, 20, 21. 5 through 12, 18 through 21. Okay? And again, questions, please call. Feel free to call or email or write down any questions in particular from the last homework set, and I'd be happy to answer them on Friday. So have a great week. I look forward to seeing you on Friday as always. Adios.